Okay, so I've started the recording. This is Design 300. We're in week 11. It's Tuesday, November 2nd, and we are on Google Meet. And we're going to finish up the last of our building systems that we're going to talk about. And that's our roofing with the sheathing and finish. So we started with dirt and we worked on the dirt and did stuff to it and dug stuff into it. And then we poured foundations and did flooring and built up walls and put in windows and doors. And last week we talked about the roof frame, the trusses or the rafters and the joints. And now we'll talk about the last part, which is keeping the rain out and the heat out and the sun out, which is your sheathing and your finish. So here we go. Wow, here's a new thing. Look at this. This just showed up. Take meeting notes. Wow, isn't that the coolest thing? They keep upping the ante on this. So can you all, I think you can all even get to that. That was really cool. That popped up there. Anyway, here we go. We're going to be doing the week 11 roofing, sheathing, and finish. We will do a little bit of Revit. The recordings will be on here. This YouTube playlist is really where we're going to put the lectures, but there's some cool stuff in here. Shingles, shingles hips, shingles valleys. These are really good to be able to see a little bit about how you put stuff on there. And I thought I had one that had some of the underlayment, but that YouTube was no longer available. So I'm going to have to look for an underlayment version of that. We've got our reading list, which is our roof systems. Make an appointment with me if you need. Now, the in the resource folder, there's the week 11 submittal template also, which I just fixed. It was wrong. I realized that I had posted last week's. So if you've already downloaded it, you need to change. This is the current one. There's a roof estimate spreadsheet and a roof estimator file. So those are all available to you. We'll talk a little bit about this production work. It's time to present your work. We're almost done. And so one of the big things in the working world is when you've finished your work, you have to present it, submit it, turn it in, get paid for it, get it approved and accepted. So this is going to be a chance to present your work and have your colleagues review it. And I'll give you some hints on that. Today, we'll go over that, and we'll go over this estimate spreadsheet. And again, as always, you've got your submittal that's due on Sunday. And here's those notes. That is really cool. I like that. I think you can all get into that too. Let's just see. What's the sharing like on that? They keep adding new things to Google Meet. That's and Google Calendar. See what the sharing is on this. I guess I should change that with anyone with the link can edit it. Now you guys can all put cool notes on there. That's kind of a neat thing. That works out really, really well. All right. So here we go. You'll go ahead and watch the YouTubes and pay attention to them. Let's take a look and see what your submittal is going to look like. As always, you've got your executive summary page, and tell me that you've watched the YouTube playlist and you've made your discussion postings. There's the roofing system, what's on the top. sheathing and underlayment, roof finish, and I want you to just look a little bit about heat island effect. The materials really do have some stuff to do with that. And the heat island effect, people are talking now in terms of environmental social justice, but even just environmentally, our building materials really affect the climate. And the heat island effect is very complex. They try to talk about it in simple terms. It's not simple. But in essence, where you build a lot of stuff, it gets hot. And having localized hot spots is not really all that great for our environment. And then there's a nice little roof estimate for finished roof materials, and that's what I'm going to demonstrate today. And so we looked over that. So here we go. I want to first go over this roof estimate. And when you download it, there's a Revit file. So you'll get into your VMware and there's a Revit file. And I'm going to show it to you. You look at it either on level 2. And there it is. There's the roof, or 3D. Now, if you want to know how big this roof is, this is a hip roof. Okay, so this is a hip roof, which means it's sloped in all of the directions. And if you click on it and edit the footprint, that doesn't show up until you click on it. It's not up there anywhere. But then when you click on the roof, you can edit the footprint. And if I click on a line, it tells me what it is the opposite direction. I can just type it in. Maybe I want it to be 40 feet. And if I click on a line in the other direction, it gives me the other dimension. So maybe I want to do 40 by 40. Now, these little things right here mean that this one is slope. That's a rise over run, this little symbol. So I click on this end. You can see there's a little check mark here that's a sloped roof. Okay, and so if I want a gable roof, I'll click on the end and I'll uncheck it. And if I click on the other end, I'll uncheck it. Now it's going to be a gable roof. Let's check and see what it looks like. There it is. Now I have a gable roof. To change it back to something else again, I click on the roof. Edit footprint button appears magically. Revit is wonderful. If I click on this end line, it lets me do it everywhere. I can put it there. I can put it here. There we go. There. So there we've got them all. Now, the other thing is I can change the slope. So I'm going to select them all because I want them all to slope the same. And the slope pops up. So I can change it to 4 on 12, 5 on 12, 6 on 12. Those ones are all common. 12 on 12, that's a 45-degree angle slope. So that's kind of cool. So that's a really big one. I'm going to change them all again. I think in our assignment, they're all 6 on 12. And that's just setting the roof slope. And then when I'm done fiddling around with it and fixing it, I always have to go up and click the green check mark. And then it appears. And look, now, since it's 40 by 40, of course, it all comes up to a peak. So that's kind of cool. If I want a ridge, I'll have to edit that footprint and make this a little bit longer. Now there's a little bit of a ridge. So that's how you manipulate making the roof. Now there's a couple of cool things about the roof. If I click on it and work down here a little bit, it tells me what the area is. I've got 2,146 square feet of roofing material to put on that thing. And that's kind of cool. Tells me how thick the roof is because I'm using wood rafter with asphalt shingle. So that's kind of cool too. So, but this is where you get it. This is where you get your area. Some other things I can figure out if I double click on here. And, oh, I don't know what I've got there. I don't know what those were. There it is. If I click on this now, I can measure from one point to the next point, and it will tell me what that length is. 28 feet. Total length, 28 feet. Okay. So that's kind of cool. It'll give me that length there. And that's what I'm going to put into that, into the spreadsheet that I'm going to use. So there's how you use this. Click on it and then the measure between two references. Measure along an element. That's actually even better. Let's see if it'll let me do that. Because it's a better measure. Where did that go? Click. Measure along it. No, it's not going to let me do that. Escape a couple of times. Let's see if it'll let me do it down here. No, won't let me measure along there in the 3D view. So you can just get those lengths from there and it'll be close enough. It's not exact because it's on an angle, but it's close enough for what we're going to do in our estimates. So that's how I work this. Click on it, edit the footprint, get your dimensions and slope as you would like it to be. And then, of course, you can take a picture of this. Another thing you can do if you want, just to get rid of extra lines, is I just highlighted those lines, right-click, hide those elements so I don't have to see them. If I hold the Shift key down in my wheel, I can take different views of it. Usually I just go to one of these corner views. It gives me the best view of it. Okay? So there we go. That's how we work with that. Now what you're going to do with that, you're going to go to this spreadsheet, excuse me, and you'll type your name in. So I've got a hip, that means it's angled in all directions, 40 by 32, 6 on 12, 40 by 32. So mine, if I click on it, should be 40 by 32. 6 on 12. And so my area is 1,431. And I can measure that ridge back to my level 2. Measure 8 feet. I've got an 8 foot of ridge. Now I have to get the other ones in there too. 8 plus, I'll call it, it's close to 24. So here comes my calculator. 8 plus 24 plus 24 plus 24 plus 24, because they're all the same. I have 104 feet of ridge, about. So I can put that in here, 104. Fascia length. What is the fascia? The fascia is, right, it's this board right there. And that goes all the way around. So I can measure it, but I should be able to just figure it out. But if you can't, you can measure it. 40 plus 32 plus 40 plus 32. I got that. 40 plus 32 plus 40 plus 32. I have 144 feet of fascia. And I don't have any valley. None of these, this particular building is going to have any valley. I didn't put a piece sticking out the side. So that's what mine's going to have. And then, of course, I'll, like what we did before, I'll turn it light orange. And I've got it. So that's what you're going to do. You're going to just march on down the line. You'll pick one. You'll put it in there. And that information goes here. You can take your given portion. There it is. I did it a few times. And that should be EAV, by the way. So I've got that. Now here's the part that is my calculation. And of course, then I want this to look cool, so I'm gonna take some screenshots. If I want to, I can even annotate this. Try that again. From one end to the next end. One end to the next end. I can put that in there if I want. The other thing I can do, that looks pretty good. That way somebody just knows about what size I did. Look, somebody can verify now that that was 40 by 32. And I might even like to take the 3D image of it. So you'll do something like that. That one doesn't look great. Probably needs to be cropped a little bit. You guys are getting much better at making these really look good. right? And you can put a little line around it if you want. You can put a little line around it just so that it kind of gets pulled out. Maybe bring that down. That's not too bad. Not too bad. Maybe I want to bring this up. You can move these. If you'd like. All kind of up to you how you'd like to do that. Okay, doesn't look great. I think I might want to play with that a little bit, but that's sort of what you'll be doing. So again, go to your Revit file. It's made for you. You just need to edit your footprint and then measure it. Okay, and that will get you your information. Okay, of course, you're going to go from end to end. And you can just estimate. You don't have to be right on. 24. That's fine. Okay, so that's your sort of spreadsheet work. This is, you all have access to do everything on it. And just start marching down and do yours. Okay? The next thing that I want to look over is posting your work. Here we go. This is our great new system. It's very cool. Keep us all safe. So you will need to present your work sometime. InDesign, your name goes on it. People question it. Not to say that you did a bad job, but they just need to know. It is very difficult to put all your ideas down on paper. And since design, the primary function is safety, safety, and safety, after that is, of course, functionality and cost, and then aesthetics, and then timing. That's why design is super interesting. Getting all that done together is really hard. But you will have to show your work at some point, and this is a great way to start doing that for peer review. Your colleagues get to see it. And right now, all we're going to do is post it. So collect PDFs of all the Revit work that you've done. Okay? And the stuff that you created or placed on a sheet. You don't need every single bit of Revit that you've touched. The things that you've done, and you've done a bunch. You've done annotations, and you've changed things, and you've put things on sheets, and now you've made a roof. Take each one of those and assemble them into a single PDF file. Okay, and that's just something that you'll learn how to do. I can show you that if you go on to VMware, you've got Adobe Acrobat. And if you sign in, there's tons that you can do with this stuff. So here, you sign in with your W number. Always doing all this kind of good stuff. Okay, so once you're in here, there's this big list of tools. You can edit a PDF, you can combine them, you can create one, you can put them in order if they're not in the right order. The main one is to combine the files. So if you create a PDF of each one, you can combine the files. Okay, how would you do that from Revit? If I want to plot this one to PDF, usually I stick it on a sheet. But if it's not on a sheet already, well, let me just show you how to put it on a sheet. Right click on the sheets, new sheet, and then load the right size. Way at the bottom are title blocks. Double click. I think 11 by 17 would be good. And then you just drag it in there, as you know. And, oh my gosh, that viewport is way too big. How do I change a viewport? Right next to the glasses at the bottom, there's a little T-square with a light bulb. And if you turn that on, you'll see, oh my gosh, it's huge. If I click on it, I can make it really small so that it'll fit nicely. And then I'll turn it off again just because. And then if it doesn't quite fit, I can change it. So there's the plus sign. There it is. There, now it's looking right. And I can do the same thing with my 3D view. Now I have a sheet. And that's kind of cool. I got a sheet. You can put your name on it and all that kind of stuff that you know how to do. And I'll go File, Export. Actually, I think I'll do a print. Print to PDF. And there it is. Adobe PDF. Now I have to figure out what size paper it is. That's one of the weird things. See, it's thinking I'm on letter size. So I need to find 11 by 17. And it's just practice getting good at this. I'll leave it as black and white. That's all I need. And I'm going to select some sheets. And I'm just going to select this one. No, I don't need to save anything. And I'll keep a separate file of it. Roof estimator, PDF. Now I have to go figure out where to put it. I'll stick it in my week 11. Okay. Yep. That's what I want to do. Now this is so weird. It asks me where to put it, and then it asks me where to put it. And voila, there we go. I've got it. If I want to combine files, I can just add them. I can find PDFs if I have any down here. So I know I've got that one. You know, add some more files. See if I can find another file. There's a whole bunch. I'll do that one. I'm holding the control key down. That one, that one, that one, that one. There they are. And if I want to move them around, I can just drag it into different order. And when I'm done, and these are big, right? These have a lot in. That's 9 pages, more pages, more pages, more pages. Combine. Now I've got this one, it's 41 pages long. right? That's how you combine files. If I want to organize the pages, here they all are. I can drag them around and just move them around really quickly. That's a really nice tool for you. It's available in our VMware. You need to log in and all that kind of stuff. But now I've got one that I can really use. And of course, I can save this now. File, save as, whatever I want to save it as. Call it my production work. Of course, that's not my work. Other people's production work. There we go. But we want just Revit files. That's what we want. All of your Revit files. Plot them, put them together, and then post them onto here. Okay. And I don't know why that still says use your graphics as a prompt. That just didn't get erased properly. There we go. And then at another time, you'll all have a chance. But right now, all I'm asking you to do is collect them, put them together, assemble them into one PDF, and post it right here. Okay, so that's our week 11 collaboration. Present all your details that you've done and any of your work. All right, so there we go. Let's see what else we've got to review and look at. We've taken care of that, the roof estimate spreadsheet, and of course you've got your submittal template to do. So let's take a few minutes to look at your roofing systems, and we'll just talk about it a little bit here. We'll do more about this on Thursday. So what goes on the top, right? Here's a wall, here's a soffit, you've got some rafters holding things up. But the rest of the roof system is a bunch of different stuff. There's rigid insulation, there's batting insulation, there's insulation baffles, there's underlayment, membranes, sheathing. The sheathing is what goes right on the rafters. That provides the decking support. Then there's usually some self-adhered membrane that is just one layer of the waterproofing. And then there's the roof underlayment, which is another layer. This is usually sort of like a plastic. This self-adhered membrane is like a plastic, and the roof underlayment is more like often the tar paper or something like that. And then you have your asphalt shingle. Now, asphalt shingle, that does provide waterproofing, but it's really tough. It's meant to be a protective layer for your underlayment and your self-adhered membrane that really keep the water out. Water can seep in and you can lose a shingle and they can get damaged, and especially at edges they can kind of leak a little bit, and you've got nails through them and things like that. But they're really toughness. This underlayment and the membrane can't hold up to wind, hail, things dropping on it. So the asphalt shingle or the ceramic tile or the cement tile or the wood shingle or the wood shake, Those are or the metal. Those are for toughness and for energy. So a darker color tends to absorb, a lighter color tends to reflect. So if you're in a climate where you need to absorb warmth, you want a dark colored roof. Absorb heat. If you're in a climate where you need to reflect that heat, you want a light colored roof. Metals are good in that they don't hold a lot of energy, but they can pass the energy. Usually they have some sort of a reflective coating, so they're bouncing that energy right back out. And that causes heat island effect while it's being in the sun, but it doesn't maintain the heat island effect throughout the night. So that's good stuff. It's all it's so dependent on your climate. And that's why climate change is such a big deal, because much of our built environment has been designed around a very specific climate. And if it changes, your buildings don't operate right, and they affect the climate differently. So lots of things here goes on here. Here's what that heat island effect looks like. It's mostly in urban areas where it's the worst. The higher you've built up, the more it is. And then when you get out to the rural areas, there's less just heat bouncing off of things. Okay, so that's what goes on top. Insulation, sheathing, underlayment, flashing, ridge valley hip materials, shingle, tile, shake, concrete, metal. This built up is sort of goo usually, solar tiles. I've got asphalt shingles all on their own because they're very, very, very popular. And then we've got this stuff on cool roof, green roof, heat island effects. So that's all available for us to look at. This is typical underlayment on top of sheathing. And if you'll notice, they're putting it across these this valley, because the valley is where you're most likely to have seepage. So when stuff gets past your shingles or shake, you want your underlayment to be protecting it. You've got your decking or your sheathing that's nailed to the rafters. You put this underlayment across, that helps protect it. You've got special types of nails that have sealing around the head. And so that's your sheathing and your underlayment to provide some support. And then, of course, you've got your roof finish. So there's roofing material, which is like shake, shingle. This is, I don't even know what that stuff is. I think that's a vinyl. And then some ceramic. And then there's all sorts of roof finish accessories, the flashing and drip edge and roof drains and all that kind of stuff. So that's all about the materials that go on the top. And of course, you've got the weight, the fire resistance, the pest resistance, the wind resistance, the durability. All of that factors into the choice, as well as just the visual appeal, the aesthetics of it. So those all go into, and shake used to be pretty popular in Northern California, but not so much. Really prevalent to fire. Lasts a good long time, but can have local damage. A lot of water, mildew damage if the weather doesn't cycle properly. And of course, the fire hazard is way, way more than ceramic tile or asphalt shingle. Um, Vinyl roofing is terrible. When vinyl roofing catches on fire, it turns into something called mustard gas, chlorine gas. So most fire departments want you to avoid vinyl siding and vinyl roofing if you can. Metal roofing is pretty cool, except it's got noise issues. So there's no perfect roof. It's always, just as everything, a combination of design factors and what is the kind of layers of importance of all these different aspects of it. And then finally, we've got the heat island effect, heat from the roads, heat from the vehicles, heat evaporation, that goes down, so the more trees you've got. Big buildings, temperature increases, heating from the building surfaces. Anthropogenic, I don't even know what anthropogenic means. Asphalt. So these are things that contribute to heat island effect. I have a feeling anthropogenic must have something to do with, yeah, mustard gas. So vinyl, PVC, polyvinyl chloride, was a byproduct that they found during World War I when they were trying to produce mass quantities of mustard gas to win the war. And the PVC was actually the byproduct. And turned out to be a pretty useful byproduct. And in its built, manufactured form, PVC is non-toxic. I mean, you can touch it, you can, you don't want to eat it, of course, but, you know, if you were to touch it and then put your fingers in your mouth, that's not so bad, things like that. The glue is not very good, right? You have to watch out for the glue. But PVC became a really cool product because it's tough, long lasting, it's lightweight. But then fire departments started finding out that when there was a fire and there were significant amounts of PVC, those who were not wearing their masks directly in the line of the fire were getting sick, and they finally figured out when PVC burns, it vaporizes and creates that mustard gas that it was originally created from. So, not good. Not good stuff. It's one of the most toxic building materials that there is, but in its fabricated state, it's pretty okay. ABS is better. Not a lot. Doesn't hold up as well long term. Copper pipe is great from that point, so long as it's not leaded copper pipe. But copper mines, there's only so much copper. So really and truly, and we're going to learn about this in sustainability, there is no great material. Bamboo, which is very, quote, sustainable, is held together and made useful by formaldehyde. So formaldehyde is not good stuff. It's right there with PVC, with the chlorides. So bamboo can be a great product, but the way it's often used, it's not good. So we're going to learn about that a little bit more later on. But it's really interesting stuff. It's a whole area of investigation that is very, very, very important when you're talking about material resources. But this heat island effect too. I mean, when you concentrate built areas, you're going to concentrate heat. When you concentrate heat, you change how weather patterns are in those areas. And sometimes you change it in such a way that it gets into a cycle that it actually creates even more heat island, which makes you cool things even more, which continues the heat island. It can get into a really nasty cycle. So this heat island effect, there's lots of things that you can do. Most of them work in specific circumstances and specific applications. And so you can't just say in general, metal cool roofs are great. Metal cool roofs can be great when analyzed and put into the right place. Using green roofing, where you put plants on the roof and plants on the building, can be great. But it takes water, and water causes damage to buildings. And sometimes water is not available. And so that can be a bit of a problem. So all sorts of these things are very interesting. And you can read about them. This is actually a really good site. This EPA site is a very well done site. And this one, Properties of Urban Materials, which you get to from the other one, is even better. I mean, this is like 22 pages of really good, interesting stuff that if you were just to take a while and read it just 'cause and not try to memorize anything, you would have some really good background material. Because there's a lot of good stuff. Why do we care about urban heat islands? So look at that. Water quality. It affects water quality. Greenhouse gases. We're only on page 1819. Strategies to reduce them. Okay, then here's a whole bunch of extra resources. So this is a really, really good little publication. I think it's not too old. When was this one done? 2008. So it's not too old. Nothing, unfortunately, has really changed since 2008. And I know that's, over 10 years ago. Unfortunately, not much has changed. So there we go. That's what we've got for this week's kind of study and work. I'm going to touch on some of this a little bit more. And but that's it. Any questions before we log off? Or comment? Okay, then I'm going to go ahead and